All right, now, so let's keep going. So this perform upkeep function here, let's give this another emit, just because I want to show you something. So I'm going to give this another event. I'm going to scroll up to the events here. I'm going to say event requested raffle winner UN256 indexed request ID. So requested raffle winner is now going to get emitted when we call perform upkeep. So I'm going to say emit requested raffle winner. We're going to get the request ID UN256 request ID equals that. We're going to emit this request ID. Now, quick quiz for you. Is this redundant? Is us emitting this here redundant? If you want to pause and guess your answer, feel free to do so. All right, I'm about to tell you the answer. So our VRF coordinator contract, if we go to our VRF coordinator mock or the actual VRF coordinator contract, and we look for request random words, we go in here, we can see there's a random words requested event, which has the request ID inside of it already. So yes, this is redundant. We shouldn't emit this request ID here because we're already going to do that in the VRF coordinator mock. So it's definitely redundant. However, to make this easier to show you us testing this, we're going to go ahead and emit it again here. And the reason we're going to do that is because in our test, we're going to answer this question. What if I need to test using the output of an event? Remember, events are not accessible by our smart contracts. But yet we're writing our tests in Solidity, so we should be able to get the output of events. Normally, in a regular smart contract, you never can, right? You can never get the value that this emitted. However, in our tests, we actually can, right? So that's what we're going to learn how to do here. And it's important to be able to test the output of events because, for example, the way the Chainlink VRF works is it emits this event here, and a Chainlink node is listening for this event, right? And this is another reason why events are so important. The Chainlink node actually functions by listening to events. And this is how it knows to request random numbers. If I'm building a Chainlink-like system, I need to be able to test for events being emitted and the values that they're being emitted. So we're going to go ahead and write a test, say function test perform upkeep updates raffle state and emits request ID. Make this public. Arrange vm.prank player raffle.enter raffle. And we probably should change this to a modifier like we did before, where we have modifier raffle entered, but I haven't done that, but we probably should go back and refactor this as a modifier. Then we're going to do the same thing, vm.warp, vm.roll. You can see this is very redundant, right? We've done this a bunch of times in here, and we should really have a modifier. You know what? I am going to make it a modifier. I'm going to copy this. We're going to make it here. Modifier raffle entered and time passed. Cool. Public raffle entered and time passed. Okay, great. We got a little modifier for that. Cool. Now we're actually going to go right into act already. So all we need to do is somebody to get in here. And what we want to do is we want to capture this emitted request ID, right? Because our VRF coordinator mock is going to create a request ID in this function here. And a raffle contract doesn't have access to this. We could go through this or make this a public variable or save it or something. But really, again, we really want to know how to test to get the output of these events. So now we're going to be in act here. And what we're going to do is we're going to use another cheat code called record logs. And record logs tells the VM to start recording all emitted events. To access them, use get recorded logs. So we're going to do vm.record logs. And what this is going to do is it's going to automatically save all the log outputs into this data structure that we can view with this get recorded logs function. So I'm going to do vm.record logs, raffle.perform upkeep, paste that in there, which this is going to emit the request ID. And then we're going to do vm.log array. So this is a special type that comes with Foundry tests, vm.log array, memory entries equals vm.get recorded logs, which is going to get all of the values of all of the events we recently emitted. And to get this vm.log, we're going to need to import that VM type. So we're going to do import VM from forge std/vm.sol. And okay, cool. So now we have it. Great. Now we can get the request ID out of this list of events that were emitted from this. And this is where we got to know a little bit about what's happening in this transaction, right? We got to know all the different types of events. This entries array is going to be a list of all these logs that are emitted. But maybe I don't know how many events this is doing. There's actually a number of strategies we can use to figure out where in this array our requested raffle winner is being emitted. Now, there's a number of different ways for us to figure out exactly what event we're working with. And one of those is to use the debugger, where we can run forge test-debug and the name of the function that we want to test. For us, we're going to cheat a little bit and just know that this event we're emitting is actually the second event emitted in this transaction. The first one is going to come from this request random words, which again is on the vref coordinator v2 mock. So if we wanted to get the request ID, we could just go looking at this location here, but we're going to use this one instead. So if I wanted to get that log, I would say bytes 32. All logs are recorded as bytes 32 in Foundry. I would say bytes 32 request ID equals entries at index 1. Index 0 would be this random words requested in the mock. Index 1 is going to be this one here. So we're going to say 1.topics of 1. So yes, even though this is the first topic in the data, technically the 0th topic, if I were to say the 0th topic, refers to this entire event. So 0th topic refers to this entire event. The first topic will be this request ID here. So now that we have this request ID, we could do an assert uint256 request ID is greater than 0. This way we can just make sure that this request ID was actually generated. If this bytes 32 is the default bytes 32, which is just going to be 0x000000, the uint256 of the request ID would be 0, and this would not hold true. So perform upkeep starts and emits request ID. We also could probably do raffle.raffleState equals raffle.get raffleState, like this, rState. And then we could also say assert rState. We could wrap this in a uint256 as well, equals 1 for calculating. So let's pull up the terminal, forge test-m, paste that in. Yay. Cool, it passed. All right, on to the next. Let's do some fulfill random words tests. Forge coverage. Stuff is looking a lot better. All right, 64%, 71%. Let's keep going. All right,